So, welcome all. Today I'm over at XFLARE. We will have a webinar talking about welding and cutting. Next to me is Patrick. Patrick is General Manager for XFLARE. Andy, who we will see later, he is the Application Engineer. And I'm Piet Koeman, and I'm responsible for the market expansion. So, if you look at our agenda, we want to show you first in a presentation what we can do with this machine. We will answer already a couple of questions. Then we have a live demo, and then at the end we will do a Q&A to answer really all the details that we have. So, Patrick, over here you developed the XFLARE, a machine that can do welding and cutting.
On one platform.
On one platform, yeah, and that is the special thing, and you don't need any knowledge concerning programming and things like that. So, what makes customers from XFLARE enthusiastic about the machine?
I think our customers are really impressed by the combination of the quality of the XFLARE, the speed, and the simplicity as well. I mean, the first you see the first seam in the morning as the same high quality as the last one in the evening. And for example, the tool change between the two processes from welding to cutting, we can do in less than 10 seconds. So it's really amazing.
Yeah. Can you mention me some highlights from the machine?
Yeah, sure. I mean, at first, I just already said the tool exchange in less than 10 seconds we have. It's the first machine worldwide that can do both the processes in welding and cutting. I've never heard of any other companies that can do that. It's plug and play. So we deliver, we set it up, and I think the customers can work with it within less than half a day.
Yeah.
So and the best is you don't need any programming knowledge. So
yeah, that is fantastic. Did you already? I mean, I understood that you put already some units in the market for 2 years to do some testing. So you already have the experience basically in the market.
That's right. We already sold the first. We sold the first 2 years ago, and it's So we already got the experience. And right now we want to launch it in Germany. We went at the Schweißen and Schneiden in the trade show in Essen this year. And we want to do the market launch next year in the FabTech in Las Vegas for the US market.
Okay. So can you explain me a little bit about XFLARE? I mean, I don't know. I never heard about the company.
Yeah, you mean the company. On top there's the Werk Holding.
Yeah.
Below that, there are the two companies, the Absaugwerk and the Extraction. Both are located in the south of Germany. We are sitting in Neu-Ulm. That's in the middle between Stuttgart and Munich. And we have 35 employees. The Absaugwerk is one of the 10 biggest manufacturers in Germany. It's a manufacturer of industrial extraction systems. We produce, we develop, and we plan all in Neu-Ulm. So it's all made in Germany. And they are experts for dry and wet separators, the oil mist separators, filter towers. I mean, everything around
extraction.
Yes.
But that's a good combination already with the XFLARE, because that also needs an extraction unit.
We need it too. And with the extraction, we are sitting next to the Absaugwerk. We have together, I just said, 35 employees. We produce as well and develop here in Neu-Ulm.
Yeah.
So we are right located in the south of Germany.
Perfect. So to develop a machine like that, I mean, you probably based it on the challenges you were facing in the metal industry. Can you explain a little bit about that? Yeah,
I mean, the documentation pressure is higher in Germany than I think anywhere else.
Yeah.
We are the specialists for that.
Yes.
We have the increasing of energy requirements.
Yeah.
We have to be more and more sustainable. I think Germany wants to be independent from the CO2 in 2045. Europe is 2050.
Yeah.
So it's I think it's a really tough way to get to this point. We have the risk for the supply chains. We experienced
that during Corona. That was quite a nice
what happens if the countries close their borders? And of course, we have the shortage of skilled workers. In Germany, I think every third position remains unfilled.
It's a worldwide problem, of course, but it's very strong in Germany.
So maybe let's have a look on our production video, and later we go on. Yeah, flexible for every requirement. That's the point. No? We have the 3 processes on our platform. We have the welding, as well as the plasma and the oxy-fuel cutting. Today we don't show the oxy-fuel because I think plasma is almost the same. We have the
Does it come standard, the oxy-fuel as well, or is that
no?
An
it's an option. Okay. It's an option what you can get, but the standard is welding and the plasma, air plasma cutting. From the components, we have the sheet metal. We can do beams, as well as pipes, clamshell heads, as well as the welds assemblies. So we can do a lot of things. And from the functions, you see the chamfering, probing, hole punching, as well as the multi-layer welding. But we have a look at some samples later, and we can show you some details.
Okay, that will clarify a lot of those things.
Yes. Here from the highlights, we have, as you said, the welding and cutting on one system. That's pretty new. We have the flexible 6-axis robotics for the welding and the 5-axis for the cutting. We can do prototypes as well as series. And you don't need any programming knowledge. So you can start immediately within 4, 5, 6 hours. So that makes it pretty easy for our customers.
Yeah, that's what I like about the plug and play. It's really, you get one system and then you can go for it.
Yes, that's right.
That is right.
So, and the tool exchange within less than 10 seconds. I think that's quite a good thing.
Yes.
Yeah, let's have a look, a brief overview about our XFLARE. We have 2 versions. We have the small one with 350 large and 2 meters wide and 280 high. We have the same in another version in the large one, 450 long and 240 wide.
Can they both do the same thicknesses and welding? And
from the function it's all the same.
But it's only size.
The size and the dimensions are not the same. So you see our XFLARE portal on top, where you can see the 6-axis tool head and the tool dock with the 2 processes. We have a sectional extraction. We have the 350 swivel terminal, which is a totally separate working station. You can do your emails, your Photoshop and PowerPoint presentation, Netflix. You can see with Netflix as well. And of course, we have the integrated control cabinet in the back of the.
Yeah, that's very nice. So you don't have any electrical cabinets that take again space and a lot of time to install.
Yeah, we have later the look on the XFLARE. It's almost that what you get. You don't need any more space.
Beautiful.
Yeah. Let's have a look at some of the highlights again. We have the tool dock with the magnetic tool holder. Andy will show it to us later. The tool exchanges in less than 10 seconds. We have the 6-axis tool head. We have the LED ring on top, which illuminates all the components. We have the laser distance sensor. We have an integrated collision box that stops the processes before we can damage anything. And of course the 6-axis for the welding and the 5-axis for the cutting. And last but not least, we have a high portal. The height of where we can work with beams is more than 50 centimeters high.
Beautiful.
So, and last but not least, our removable drawers. And of course here we have a look on the teach wheel, and you don't need any programming knowledge, as I said before.
Yeah, that is really nice.
Yeah.
Okay,
But
shall we have a look at the live demonstration?
Perfect. Let's go on and let's see what Handy can do for us.
Okay. So let's go to the live demonstration. Hey Andy. Andy is the process engineer for the machine. Can you explain me something about the XFLARE?
Yeah, for sure. Hello, Pete. Welcome.
Thank you.
This is our XFLARE in live. I will show you a short presentation of all, so cutting and welding. We will move very fast because we are short on time, but you can ask as many questions as you want. And
okay.
Yeah.
Well, you have a terminal over here. We discussed that you can do the 350-degree turn. What can you do on? Is it a normal computer or is it a PLC? What is it?
It's a normal computer, yeah. So you can see we can move this. I can also move it over here. I leave it like this so you can see the terminal. And this is a Windows computer. We have installed several free viewers, so you can just inspect your production files. Yeah. And the customer can decide whatever workflow he wants to realize. He can install email programs for his workers or manage interaction with construction. And the special thing is here is running our in-house software. So we have done a special software for cutting and welding. And the reason we did this is we were looking into other external softwares, but these were not flexible enough. We had a lot of requests from users. We have a lot of ideas, and we wanted to be able to realize all ideas, and that was only possible to do it on our own.
Okay. Can you show me the 6 axes that we discussed during the presentation?
Yes, for sure. So I have this, it's called a hand. We call it hand wheel because it really has a wheel. And I can just here very nicely control the machine. And it can move like this in the directions, and it can move up and down. We have 3 linear axes. And then the specialty is we also have these rotational axes on the top. And you can see we have these 2 axes, which you normally know from a cutting table, which can also do bevel cutting.
Yes.
But this machine is a full 6-axis portal robot. So we have a 6th rotational axis here, and this is a feed-through axis. So you can really move 360 degrees and more in both directions. And this is very important if you want to do welding, because then you can reach your parts from all directions on the full working area, and you can do complete surround seams with overlap.
Can you do this with a cobot, for instance, as well?
It's difficult. So this one is like a real robot, has much more flexibility, and you can look at this huge workspace you can reach. Mm-hmm. And with a cobot, you normally have a different setup where you cannot move completely around.
Okay. So what is the maximum height that you can travel over here?
This is 550 millimeters, okay. And we did this for 2 purposes. So the first one is that we can place larger work pieces on the table, and the second requirement was for our beams. So if you look on the steel beams, they normally go up to 330 millimeters, and then they go in the width. And you can even feed these huge beams through the machine and work on them from all sides.
Okay. Can you show me something about the tool change so that we go to the cutting?
Yes, for sure. So if you operate here in manual, you can very nicely control the machine. But this software, when it runs here, it is the machine. So if I move the tool here, I have the information in my programming environment. And if I do something in the programming environment, I directly have the information on the table. And the programming environment allows me that I can, we call this half supporting actions, and I can trigger them from here on the data, and then the machine will just move alone, and I can allow the machine to move. And for example, this is a small, I can just request the machine to move to the tool exchange position, and then the machine just moves over, and I can come here, and we have, like in a robot, we have this magnetic collision box. So this has two purposes. First, we protect our machine, because if we have a collision, then the magnetic collision box, it will just loosen, and the machine will stop instead of doing a crash and destroying the tool. And also the machine is an open system, so it just doesn't move as fast as a full robot. So never a user ever managed to destroy a tool. So it just will stop, and you don't have to worry that you damage something.
I also hope that the tool doesn't destroy the operator then.
No, of course not. And we use this magnetic toolbox for our tool exchange. So you can very easily just loosen the tool, and you can place it up here in the tool dock, and then you can take the other process, and if you put it here, it will automatically snap magnetic into the position it's encoded, and there are switches on the plate so that the machine automatically recognizes which tool is in the machine. And if I then just acknowledge the machine once, then the machine completely switched.
So now it knows directly the new position for your cutting head, and you don't have to do anything.
You don't have to do anything. Now you have a full 5-axis cutting table. So if you look, the machine now knows the tool, and it's completely moving different. The complete kinematics changed to be a cutting machine. The full software reconfigures to be a cutting software, and you can now do either steel plate production or beam production, whatever you want. In this case, we have these weld bars. This is optional. You can install them, and we just place them here. So we can show the welding later.
Yes.
But of course, you can just move them away. And then you have this work area, which you know from a normal cutting table. And this one is a large machine version with 3 by 1.5 meters for the larger steel plates, and you can just produce them here.
So what would be the maximum thickness that you could do?
This one is, we have an air plasma system here. It's a GUS NeoCut. It can cut up to 125 amperes. And you can cut up to 20 millimeters very nicely. And we have also a drilling unit which can be installed on the side here, which you can then bring down, and you can pre-drill, and then you can even cut up to 35 millimeters with the plasma. Yeah,
and with
of course,
because we discussed the option. We will not show it today.
Yes.
We discussed the option. What can you do with this one?
You can cut higher thicknesses. With the autogen process, you can just install it up here, and the tool change is the same. It's as fast as you just...
But will you add a third station, or will you keep 2 stations in this case? So you will leave the plasma, will go away, and you will put
No, you can install all 3. You have two tools can be up here, and one will be down here. And with you will install a gas box, and this one has internal ignition. It has and the full pressure control, pressure ramps are all controlled by our software. And by the way, that's also for the plasma. All parameters that you need for cutting are in the software. So you don't have to be an expert. You only have to select the material, the thickness. If you have the plasma, you might choose which nozzle and ampere strength for cutting you use. And then, you get a suggestion for your parameters. And if you're a power user, you can tune them if you want. But with the normal parameters, you can just cut very easily.
Can you show me how you would set it up?
For sure, yeah. I can go over, and this is also like a small gimmick which we did here. I can just just move the machine over here. And I mean, we will do a small beam demo here. Normally, you will not place the beam like this on the machine. This is a special demonstration.
Yes.
But yeah, we did. I just programmed 4 points over the beam.
But that's what you did with the teach-in then?
Yes, I did this a couple of minutes ago.
Okay.
Before the show, I just programmed these 4 points. You see where he starts,
yes.
where the machine starts searching, and then it finds the surface. And once it finds the surface, it does another search from the side to find the exact position of the beam. And this is a short snippet which you can just trigger. Normally, you will not cut the beam like this on the machine, but I mean, it could happen if you have already produced or welded something on the beam and you need to do some additional work on it because there was some error. You can do it like this, but normally you will place your beam on the table, you will measure it once, and then you can produce your 20, 40, 30 beams.
There is a nozzle inside. Eh? How do you know that the nozzle is worn out? Do you track that, or do you have to do that manually?
We have a tracking how long the nozzle has already cut it, and how many ignitions it has, and this will be tracked so that you see in the software when you need to exchange the nozzle. But the nozzle exchange on this air plasma, it's very easy. You don't need a tool. You can just screw the nozzle
by hand
away. You exchange your parts, and it's very easy to assemble.
Okay. Can you show?
Yes.
The next step. If you have
this was the fast search. I can then accept that, and for example, I can just show you that it found the tool. I can just move a bit up, and I can command them to move in the beam. And yes, you see the beam was found. And I was now just loading a DXF file and placed it on the beam. And I can just execute this small program, just some markings. This plasma cutter, it can mark and cut. And you can switch from the marking to the cutting process without any gas change and also without any nozzle change. So it just can switch between the two processes in a second.
So now it is doing a very strange rotation, I would say.
Yeah, exactly. The reason is if you do plasma cutting, the plasma, the arc is not straight. So if you cut like in a normal 3D table, flat, then your cut will be not straight. And this one uses the 5 axes of the machine to do a non-straight cut, but in the end, your cut will be straight because it will correct.
So this is basically the thing I'm playing with here all the time. That basically was not done for playing; it was done on purpose. So this is normally a hole that you would make, and that doesn't fit in. And these are basically the straight holes that you can make when you put the head under an angle and use the 5 axes.
Exactly. You can also do long holes. And I mean, normally you can just make the hole larger, but then you have the problem that you're out of tolerance.
Yeah, sure.
And with this cutting process, you can produce very nice holes.
Okay. Can we go back to the welding? So that we change the tool and that you show us how you would set up for the welding?
Of course, we can do that. I will move over and exchange the tool again. We will also cut the beam, but we will do it later in one go.
Yes.
So let's switch back to the welding process. So that's it. And yeah, you see it's very easy to change the process.
Can you do me a favor? Can you remove the cap? Because
I can do that, yeah.
Because it's maybe easier that we see it later.
Yeah, we can do that. Then you can see better what the machine is doing. We have this tool. You can cut the wire to the correct length if you want to do some teaching. It needs to be on the correct tool center point. And I can remove the cap so you can see better what is happening.
So you did the same thing over here again. So what you did with the teaching, you took a couple of points from the part over here, and now you will let it do the machine itself.
Exactly. I just teached a few points. I will just execute. I will just execute the search because the machine can automatically search the points. And while it is doing so, I will explain you a bit more. So. You now see that the machine starts moving, and it does some very complex touch-ups of the points. And I can show the tool here, the part here. This is the part we produce. It's quite simple part, but not so simple. We have some round seams in the inside. We have some seams on the outer where we switch from a straight line to a round seam. We have some riser or faller seams which we want to produce. And we try to program this with the least amount of points. So we did 4 points in the inside. We did 6 points on the outside. And for each of the seams, we did 2 points. Here, this is about...
But it's a pretty small hole that you can actually go in with the welding then.
Yes, exactly. You can access with this kinematic. You can access the part very nicely, and you can also do much more complex parts, larger parts, parts on the machine. And I just programmed this before the show. This was 14 points. It took 5 minutes because you see. The machine where it starts searching, this is about 10 millimeters above the surface. I just teach these crude points, not the exact points, and then just commanded this one is an edge point, this one is a point on the seam, and the machine will then automatically select these searches. And it will just take a couple of minutes, but you will only do this once.
But if you have now, we have now multiple parts we have on the machine. Do you have to do it for every part, or do you only have to do it once?
You only have to do it once. So this is very important. We have the software reproduces the normal workflow of the user. So in real life, you have parts, and in the software, you can define parts. You have seams on your parts, and in the software, you can define seams on your part. And then you can just place the part multiple times on the table. You just define 3 points on your surface, which you say these are my reference points. And if you then put the part on the table, you can just go to these 3 points and measure them, and then you have one placement. And if you put the part on a different position, you can measure the same points and you have a second placement. And these placements, they share the data. So this means that if you change some welding parameters on one part, all parts change.
Yeah, so what I understood is you can do some parameter tuning as well?
Yes, we can do so. I will just let the search finish, and then I can execute the path, and you can see the accuracy. Also, if you in the inside, if you want to program that by viewing, it's very difficult, but with the search, it's very easy to do. Also, like this. This is inside weldings. And you can program this by hand, or you can load your CAD file and then put these pre-search positions from the CAD file.
So how do you find your optimal speed that you want to go? Because at a certain moment you want to have a certain thickness of your weld. How do you know your speeds? Are they in the program, or can you speed it up?
We have we call this tracks. You have a lot of tracks where you can program your different weld parameters, and one of the parameters is the aim thickness, so the size of your seam, and you can just select the seam size you want to produce, and then you can select which characteristic of the welding source you want to use. And then the wire feed must fit the motion speed.
Yes.
And this is automatically calculated in the software. And you can even tune this. So let me just execute this, because we are now done with the search. So we can also see how accurate we are now move on the part. And by the way, you see this, I mean, this was probably not visible in the camera, but there is a teach mode. This means the welding source, it recognizes when the wire is hitting the surface, and it will retract the wire so that you do not, that the wire stays straight.
That you are not bending it.
Yes,
basically.
Exactly. And look, it's moving very nice on the path, and this blends here, for example. The blend in the edge and then back to the perfect weld position. On the tracks, you can just very easily define the perfect welding angle and the blend distances at the edges very easily. And if I, for example, now go here, I can just reduce the motion speed or go up. And the machine, I can even do this while the process is running, and the machine will adapt the wire feed in such a way that your weld size stays exactly the same.
So you will not see the difference even when you are playing with the
No, you will not see the difference. Very tiny, but no, it will stay exactly the same size, and you can then just go with speed up. You can start slow. You can just, while it is welding, go up until it gets unstable, and you can find your perfect weld parameters very easily. You can see it can also weave. It will also hold the perfect weave angle over the full path very easily.
So when we fill up the table, do you need an operator, or can it just weld on its own and the operator can do something himself?
It can just weld on its own.
Okay.
Yes. You can just, we call this half autonomous operation and autonomous production. So you can just fill up the table completely, and then the machine can run for 30, 40 minutes, and your worker can do other useful stuff.
Yeah, so basically you can do the preparation for the next set that you put in there.
Exactly.
Can we do some real welding and some cutting?
Of course, yes.
Okay, let's do that. Well, Andy, thank you very much for the professional demonstration, and we learned a lot this afternoon. So a small recap from what we have learned today. I mean, we learned already that within 4 to 8 hours you can operate this machine. The tool change, we can do that within 10 seconds. We have seen that several times, so this is already great. Thickness of material we can cut up till 80 millimeters if we use the autogene system, and 25 millimeters if we do the plasma system. So those kind of things we already discussed several times, and I mean, the question from the viewers, but I mean, this is already answered. How reliable is the angle correction when cutting holes and chamfers?
Very, very good. This is has very good repeatability. You program it once and then it will execute the exact same path all the time.
Okay. How does the XFLARE react in the event of a collision or operation area? Does the system remain protected?
Yes, I mean, we already talked about that too. So we have this collision box. So if you have a crash, it will automatically stop. You have there a button which you bypass collision. You can just press that and it moves slower. You can just move a bit back and continue.
But will it continue in the process, or will it go back to his rest position and start the process one more time?
No, you can then restart from the exact same position.
Okay, that is very nice. How is the maintenance carried out, and which parts need to be replaced on a regular basis?
Normally, you don't need to replace parts on the machine, so we have very high quality parts. You do one check each year, and you can get replacement parts, of course, but you don't normally need it. You need to do, like in any machine, the lubrication. You need to look at the bearings, but then you only have your parts for the process equipment, which you of course need to replace with the processes running for some time.
Okay. How well does the XFLARE compensate for the material inaccuracies?
Well, also very good. You have seen the laser sensor, you've seen the touch-ups, and you can very good compensate for deflections of the material. We have the height control in plasma cutting. If the plate is not, if the plate is bent a bit, so it will automatically correct the height. There are quite a lot of features to do these corrections.
Okay. Well, these are the questions that we had from our viewers. If you still have questions, I mean, send them over to us. Maybe there will come some more questions later on. Don't worry, send them over to us, and Patrick will finally answer these questions on a later stage. Yeah. Patrick?
Yeah, thank you very much, Pete, for your time. And thank you for the audience watching us. If there are any more questions, do not hesitate to contact us. And thank you, and see you next time.